Good afternoon, class. This is Tim Tomlanovich. I'm still in Learning Plan Part 2, or I'm sorry, Learning Plan 2. This is now video recording Part 3. All right, so I'm in the Blackboard shell under class materials. So if you go into Learning Plan 2, lecture materials, Learning Plan 2, I want you to, let's take a look at the homework, okay? Homework set 2, all right? Okay, so basically, listen to find 4 techniques used to increase shear strength of aggregates. Where do I get that from? You get that from reading Aggregate Handout 2, read Aggregate and PCA. PCA is your textbook, okay? Portland's Cement Association, okay? And then you're going to review ASTM C33 WSDOT standard specs, and then problems homework set 2 with graphs. So going back to homework set 2. Research the Wisconsin Department coarse and fine aggregate specifications for concrete. Section 501. Compare the size requirements for aggregates used by WSDOT. Find number one coarse, number 2 coarse to ASTM C33 size requirements. Both references are on the Blackboard site. Answer the following questions. 2A. What ASTM coarse aggregate gradation specification do the 2 WSDOT coarse aggregate specifications most closely match? Explain any differences. For each example, WSDOT course number 1 is the same as ASTM size number 3, or WSDOT course number 2 is similar to size, but there are differences on the number 4 and number 200 sieves. Okay. So let's take a look at those now. So basically first you're going to do this on engineering paper, right? You're going to letter and print all this. You can just put problem 1, problem 2A. Okay, so if I go to content, let's open up ASTM C33. So if I look here, I scroll down, okay, you want to look at table 3. So what I'm going to try to do, here we go, let's see if I can rotate. I want to rotate clockwise. Okay, and let's zoom in. All right. So if I look at table 3 in ASTM C33, these are ASTM size numbers, 1, 2, 3, 357, 4, 457, etc. Okay, so reason why most concrete plants in the United States, or probably even around the world, they only have select amount of sizes. So basically, quarries and aggregate companies can make these sizes. Could you imagine if we had like millions of sizes? That way we can design our concrete mixes using this most standard stockpile sizes that are made across the world, okay? So if I look at this, size number 1, nominal size, okay? Remember, nominal size is not the maximum size, okay? It's the size that is, some of the material is, most of the material is permitted pass. Remember, we can have 90 to 100 and 90 to 100% passing this. So if I look at this, this is from 3.5 inch to 1.5 inches. Okay, nominal size is 3.5 to 2.5. So if I look at um, the 4-inch sieve, 100%. These are percent passing. 100% has to pass. This is my nominal size, 3.5. See this? 3.5, because we can have 90 to 100% passing the 3.5 inch, or we have 10% passing, right? Okay, there's no spec for 3-inch, and then we need 25 to 60% passing the 2.5 inch, and then 30.5 we need 0 to 15, 19, 0 to 5, okay, and so forth. So if I go down to these, let's just look at stone number 67. Nominal size is 3/4 inch to number 4. Okay, so if I come across here, shoot straight across, okay, and if I look, my 1-inch size has to pass 100%. So if there's anything retained on that 1-inch sieve, that means this does not meet stone 67. Again, 3/4 inch is the nominal, so it's 90 to 100. 3/8 inch, 20 to 55. Number 4, 0 to 10. Number 8, 0 to 5% passing. Okay? All right. So, all right. So how do we know? So, number two, or the number 200 civ is where the percent fines pass. Okay. So I'm gonna rotate this back. All right. There is also another table right after this. Okay. Because how much fines can we accept? So actually, we look at table 4, rotate clockwise. All right. Class designation of concrete. Okay, so basically, if I'm designing something, I want to look what kind of class I'm in. What am I using that concrete for? Okay, and then you can find that. All right, so if I look clay lumps and friable particles, so we have seen that before, haven't we? Okay, I've talked about that. So this is percent passing. So there's a test, so we can only have this amount of passing. Okay, chert, less than 2.40 specific gravity. Okay. Sum of clay lumps, friable particles, and chert, right? So this is what we can have, all right? And then material finer, there we go. This is the big key, right, right there, okay? Is material finer or passing the number 200 civ, which is 75. See that little term right up there, 75 the micron? That is a micron. They call it a micron. So it's 0.075 millimeters. Okay. So if you look here, we can only have 1% passing for any of these stones can only have 1% passing the number 200 civ to meet qualifications. However, you see this side note C. This percentage under either of the following conditions one is permitted to be increased to 1.5% if the material is essentially free of clay or shale. That is not true for us in our region because there is that bedrock shale layer as you look at the bedrock, the Wisconsin bedrock map. Okay, so we can if it's free. So we don't want to do that. So we want to say 1%, 1.0%, because it's less than 10%. So I'm keeping it as a decimal. 2, if the source of the fine aggregate to be used in the concrete is known to contain less than the specified amount passing the number 200 civ. The percentage of the amount of course that is permitted to be increased, L equals 1 plus P 100 minus PI. Okay, so that's a little complicated. All right, so that's like a formula. Don't really worry about this guy. So normally we want to stay in here because we're not essentially free of shale. Okay, so 1%. I've never used this formula in my career, but it's a way that you can basically what this is saying. This is a way you can increase the fines depending on your fine aggregate. All right, so if I look, okay, so we want to hold it to 1.0%. Okay, then we have coal and lignite. Remember, another deleterious material. Okay, abrasion. Okay, so that's the LA abrasion machine. And then magnesium sulfate soundness. Remember that term soundness. So that's a special test, 18%. Okay, all right. So that's how we know for coarse aggregate. Now, so here's these stones. So what I'm asking you is which one of these stones will match the DOT coarse aggregate? And I'll go to the DOT next. So let's go to table 1. All right, rotate counterclockwise. Table 1, grading requirements for fine aggregate. There we go. 9 points. So the first sieve is 3/8 inch. So 100%. Number 4 is 95 to 100. So that's the nominal, right? So number I define coarse aggregate is material that's passing the number 4, but retained on the number 200. All right. So remember, we're allowing a little error in there. Okay. Number 8 is 80 to 100. Number 16 is 50 to 85, and so forth. So let's look at number 200. A and B. A, for concrete not subject to abrasion, the limit material finer than number 200 civ shall be 5% maximum. Okay, where am I using? So roadways, you're subject to abrasion. Concrete foundations, you are you're not subject to abrasion. So I could increase that to 5% if I was just using it for foundation because they're buried underneath the earth. B, so for manufactured or recycled aggregate, blast furnace slag, if the material found in the 200 civ consists of dust or fracture essentially free of clay or shale, this limit shall be 5% for concrete subject to abrasion and 7% maximum for concrete not subject to abrasion. Okay, that's a tough one. How do you prove that it's free of dust, free of clay or shale? Okay, that's a good question, right? So typically, we can bump that up to 5%. All right. Or if you're on a roadway, you want to go to 3%. So we'll see. Well, because DOT deals with roads, right? So those roads are dealing with abrasion, so not subject. So we're going to stick it at 3%. Okay. So going back and here's some deleterious material for fine aggregate. The percentage is allowed right here. Okay. So if I go back, I just want to read this note again and see if we can figure this out together. All right, rotate clockwise. All right. Okay, 2. If the source of fine aggregate to be used in the concrete is known to contain less than the specified maximum opacity, the number 200 civ, so that's 3%, the percentage limit, L, on the amount in the coarse aggregate is permitted to be increased. L equals 1 plus P divided by 1 minus P. Okay, and T minus A where P. Holy moly, we're just going to ignore that. So this is a little more advanced than what I want to talk about right here, but I could figure it out. This is what you're going to have to do when you are doing this, is that you may have to spend time to figure out what this is saying and do this calculation and see if it makes sense. Okay. So even to this day, I'm still, as you can see here, I don't even know what that means yet because I have to take time to study it. But just we're going to assume our materials are not free of clay or shale, so we're going to stick to 1% for coarse aggregate. Okay. All right. So I'm going to keep this open, and then I'm going to go to the WSDOT specs. All right. So we need to go to 501 structures. 501 concrete. All right. So if I go here, here's water requirements, sampling and testing, deleterious material, material passing the number 200 civ, coarse aggregates, fine aggregates. Okay, fine aggregate consists of this. Okay, so the fine aggregates, our answer is 3.5% by the DOT. Okay. Reduced to 2.3% if using grade E concrete. Grade E concrete, I don't know what that is. So we'd have to go. So when you're reading this, you have to go find out what grade E concrete is to figure out what I'm using this concrete for. But right now, when I look at this fine aggregate, it's 502.2, 501.2.5.3.1 is a subsection of this. We can go 3.5%, or we got to reduce it to 2.3% if we're using E concrete. Coal, clay lumps, shale. Here's what they limit. Okay. All right. Organic impurities, mortar strength. So here is the percentage of fine aggregate size requirements. 3/8, 100%. Number 4, 90 to 100. That's our nominal. 16, number 50, number 100. All right. Okay. So if I go back and forth, oops. If I look at, let's see, this guy. All right. Let's go to the fine aggregate table. Because if I look at, that thing is getting in my way. All right, we'll do this. Let's get to the homework. Yes, I am there. So I gotta, I'm just gonna pause this. I can't. All right, sorry about that. I'm trying to figure, okay. So if I look at number 2B, 2A was course, we're gonna compare course. Now that I'm talking about fine, let's go to 2B. Does the ASTM fine aggregate gradation specification match the WISDOT fine aggregate specification? Exactly. If not, list the sieves that are different. All right, so now if I go back, okay. All right, so here, okay, here, okay, 3/8 inch sieve, 100, okay. Now let's go back to ASTM. Let's find our fine aggregate right here. 3/8 inch sieve, 100. Those are the same. Okay. All right. Number 4 sieve is 90 to 100% passing. I go back to the ASTM. Number 4 is 95 to 100. All right. Let's check that again. Is that different? 90 to 100. 95 to 100. So you're going to say 3/8 inch sieve matches WISTA and ASTM match. Number 4 sieve, ASTM allows 90 to 100. WISTA or ASTM or WISTA allows 90 to 100. ASTM allows is 95 to 100. That's different. Okay. Then let's go to number 8. Okay. WISTA does not have a number 8 sieve. Okay. So that means you can write that down. WISTA does not have a number 8 sieve, but ASTM has a number 8 specification. Okay, is that so? Hopefully you can kind of see. All right, so if we go down to number 200, we have 3%. Okay, our concrete is subject to abrasion. We have 3%. If I look back up to here, WISTAT allows 3.5%. So we got 3%, 3.5%. See the difference? So that's what I want you to do is to look at the difference, go sieve by sieve, and figure, okay, WISTAT is different on this sieve versus ASTM because this way. Does that make sense? So, okay, so now let's do the course aggregate question. That's question 2A. So all right, rotate clockwise. All right, so let's go back in the spec. Let's find course aggregate. All right, so here's course aggregate section right here. Okay, here's deleterious substance. Okay, flat and elongated. Material passing the number 200 sieve. They have 1.5%. Number 200 sieve, 1.5%. All right, so if I go to here, this table, no matter what concrete I am, I'm at 1%, right? Because it's not free of clear clay. It's not, we're going to assume it's not free of clay or shale, okay? 1%. So there's a difference already, okay? So that's different. All right, so we know that's different, but now we need to match. So WISDOT has 2 and AASHTO, American Association of State Highway Transportation Officials, okay, size number 1, size number 2. WISDOT only uses 2 course aggregate sizes. So we need to match size number 1. Their first sieve that is 100% passing is 1 inch, okay? Let's go back up to here. First is 1 inch. So let's find the 1 inch sieve. It's right over here. And we go find the first sieve that passes 100%, which is either the number 6 or the number 67 stone. Okay, so I just already narrowed it down because the 1 inch sieve for size number 1 in the DOT is 100%. So it's either going to be this or this. All right, going back. Okay, so 3/4 inch is 90 to 100. Okay, I go back to this one. 3/4 inch, 90 to 100. Well, I'm still either number 6 or number 67 yet. Okay, the next sieve that ASTM is 1/2 inch. So let's go to 1/2 inch. So WISDOT does not have a 1/2 inch for size number 1. Okay? So if I look at half-inch, so stone number 6 has a specification, okay? But stone number 67 does not have a specification for half-inch. So looks like we're on a roll to matching number 67, okay? So now we're not sure yet, so we got to check the rest of them. So 3/8 inch, 20 to 55, 20 to 55, that matches, okay? And number 4 is 0 to 10. Number 4 is 0 to 10, and number 8 is 0 to 5. Number 8 is 0 to 5. So bingo, we found a stone that matches. So basically what you're going to say is ASTM C33 size number 67 is an exact match to Wistat size number 1, with the exception that the fines for ASTM are this and the fines for Wistat are this. So we do the exact same thing for size 2. Okay, so go and compare that. Okay, hopefully that makes sense. All right. So I just wish I could find a way to. All right. So that is 2A and 2B. That makes sense, right? Okay. Problem 3 is calculate the results of the sieve analysis for the following 2 samples, 3A and 3B. Lay out the sieve analysis data similarly to the example we discussed in class. Calculate the pan weight, percent retained, cumulative, percent retained, and percent finer. All results should be rounded correctly as we discussed in class. Okay? So you can set up a nice little graph on engineering paper. This is your dried unsample weight. This is your sieve size. Okay? And here's your weights retained. So you have 2 different problems. Okay? So you're going to do all those calculations like I just showed you. All right? So you notice something though. We have inches. Remember, when we plot the x-axis, which is sieve size, this has to be in the millimeter. So that means you got to do a conversion. You can look it up, look under ASTM standard. Okay, Google it, figure out what these are in millimeter. There's lots of standards. Okay, so that's 3. Number 4. Then you're going to plot as shown. Remember, you need to convert size to millimeters. Okay. Number 5. Determine the uniformity coefficient for both gradations. So just like I showed you in the video. And then determine the finest modulus for sample 3B only. Okay, so that's this guy. All right, determine that for this guy only and show on engineering paper. All right, so that is that homework. This homework, okay? So with that, I do believe that concludes homework set 2. So I just finished going over WISDOT 501 and WISDOT 50 or ASTM C33 at the end of this lecture. So I will, and then homework set 3. Basically, you read this aggregate handout. Okay. Then you want to answer these answer these questions. Okay. So make sure this is a separate set. This is a separate set. Homework, separate submissions. Okay. And if you remember, you want to submit it all as a single PDF. So here's your blank semi-log paper. Okay. Remember, you're going to put it all in one PDF and you're going to scan it to me. So that ends this lecture. So if there's questions, you know where to get a hold of me. Thank you.